Now let us see templates today in our data structures. So once we have cautiously implemented a class like list or stack or queue, and we may really find it out that it is quite good, but we would like to have a list or stack or queue of strings. What I'm trying to say is we have made these three, but now I want it for different data type, and for some user for web page and so many other types of object, means different people different requirement. What is the solution? The obvious solution would be to copy the code we have written for the integer in previous discussion and then just replace the word int by string everywhere. Is it possible? This is possible, but this will cause a lot of code duplication. Redundancy will be there. So in specific, just imagine how or now that after making this 20 or different number of copies, we actually discover that original implementation of list have some bugs. Now what you are going to do, you are going to debug these, say, n number of copies, right? So what we would really want is a mechanism for creating a generic list class. We really need this, which enable us to substitute any type of data, not just integer, not just string, but making it generic so that other data types can be easily embedded. In this or by this way, we are going to avoid the code duplication and all the problems related to it, like debugging and version control, etc. So C++, as we are in our data structure classes, we are talking about C++ immensely. So for C++, the mechanism for doing this activity is actually the templates. Templates, we have already used this using this C++ STL standard template library. We have discussed this already, and even we have worked this vector, this angle brackets. This is the syntax for creating your own template class, which is in a first view it may seem somewhat different, but because of the specific way in which this C++ is actually implementing it, we have to work it upon. And once you are encouraged by using, or you are familiar with the coding, then it will all be easy. So it was actually not the part of C++ design initially, but after it was added, and it actually fits quite smoothly. So how we are going to define templates classes, and this is using template. This is the keyword. Then you have class T and struct item. This is the data. This T is for any data type. This T is for any data type. Then you have item, and the angle bracket you have T, again a data type. Then previous and next. So this tells C++, this particular thing tells C++ that we are defining a template class which will be generally based on another class, right? A template class based on another class, and we call that class T for now. Class is T for now. We don't know that class because this is class and this is T. We don't know that class. And by writing or imprinting this, we can treat this T as though it were an actual name of an existing class. So what really happens is, suppose that in some later code we want to create an items for string like this. Now we would do, just by using this construct, simply item string, this iterator, and use item string. This angle bracket has been replaced with our string. So when compiler goes to this code, it will actually copy over the template code, and whenever it sees T, it is going to substitute T with your string, right? So it will exactly do the text replacement that we wanted to avoid doing by hand, right? So we only maintain one piece of code, so no redundancy will be there, and then rest is generated only at compile time, which is automatic. So this is how template comes to our rescue and saves us our work. Hope you remember our linked list class, what we did, and now we'll do it using this template. So this was template class T class, then this was linked list, and we have public linked list. This is our constructor, destructor, we add function, remove, and now we have item T, right? Then print list, then item T, that is the head. So when we implement class functions of template class, the syntax would be quite easy. Template class 3 and linked list T double colon add. So we simply use this T using this add, as we have this function called add. So now the template class T line and this T is in the same, they lie in the same class name. So you have to put these in front of each member function definition, otherwise compiler would not know that you are implementing a member function of the template class. So if you sometimes get an error called template undefined, you might have missed this angle bracket inside which you have T, and you have to note that this identified T is arbitrary. You can use T, X, or your name even. So please don't think that only T is written, but this is trivial. So by virtue of usage, programmers have actually, or the designers or the teachers, they have been using this T. So the keyword template cannot be used just with classes, but also with other things. For example, functions. We can write template class y and this y minimum ya yb. If a is less than b, then return b. So this y, this y, this y, and the return type y and this y, this all are what? They are simply your T or data type, and you are not placing it here. You are leaving it or making a template class so that the other users can actually put there or they replace this y with some of their data type. Another thing which is to note is on specifically about template is that you can't just use one type. You can use multiple types. How? For instance, remember the map. Map has what? It is a key value pair. So it can be easily specified as template. You have this key type, you have class, this key type and value type. So key value pair. Then you have this class map. So templates were kind of grafted on top of C++. It made and not really part of this initial design. So that is why you can very well see that the syntax is quite unpleasant, and the way of doing things cause all kind of compiler and link problems. So in order to get things work, you have to sometime need to deviate from good coding practices. For instance, having to include hash include of a .cpp file. This also you have to do, which is not advisable. So read it cautiously before attempting to code templates, because template, though it is easy, but it may create a lot of problems, as I just suggested. Then coming to const keyword, because of this type, which is we referred as T, this could be large, such as custom type. Just think about a linked list, each of whose item is a vector of some complicated structure. So it is usually preferable to pass the parameter by reference to avoid copying the whole item. If you want to send the whole item, then if the items are large, there will be trouble. So pass it by reference. And the Other reason is that you may not be assured that the class that would be substituted for this T actually implements a useful copy constructor. It may make not a deep copy but a shallow copy and may cause difficulty in later uh, usage. So we would revise the syntax of the definitions like this: template, class T, linked list. This T all are our data types. Add T ampersand value, right? We have already seen about add, and now this add we have seen. We will just change it somewhat in this manner. Add T ampersand value. This ampersand value, because value is passed by reference, it becomes susceptible to overwriting also. This is also a trouble if you the function add would be allowed to change the fields of value. So if another person sees only a function signature, how can the person be sure that the value doesn't get overridden, because you are actually passing it by reference? So they may be worried about the side effects of this add function. And the way to solve this is to use the constant keyword. Hope you understand why we are discussing it inside const. You want it to pass through reference, but while passing it will overwrite, it may overwrite, the function may overwrite things. So for that you can use const keyword. How? Const T ampersand value. And then the code, so by adding this const we ensure that the code inside the function cannot alter the value of or any of its field if it is more complex variable. So if we include code that tries to alter the value, the compiler is going to return an error, because the main point of const is to make it clear to other using these functions about what can and what cannot happen to the parameters. We can also use it like this: linked list, then T, then print list, and then const. This is how this is another way. So in this particular case, what this constant says is that the function print list will not change the object on which it is called. That is, after it executes, the object will be in the similar state. So this means that the function cannot alter the variables of the object, and it is quite beneficial to mark all the const function as such. Just imagine that you are passing a linked list as value into add function above. In this, and you could still call a value dot print list, since it is guaranteed that it cannot alter value. That is why you have used const, and therefore it does not violate the const part of the parameter. There are some other considerations also. Friend functions, and friend functions require some extra care when you are actually combining this with defining your own template classes. How? When the function you want to declare as a friend takes a template parameter, because your class is templated, you need to say so inside the class definition and give it a symbolic definition name, just to avoid any ambiguous nature or ambiguity. Let us take an example. Suppose you want to implement a generic multiplication of an integer with an array. Maybe it concatenates the array with itself some number of times. So you need to overload this operator and declare because multiplication you want to overload star, means this is actually for multiplication, and declare the operator friend of your array list, right? You have template, you say class array list, other stuff, then whatever you want to do, then you make friend this operator star. So notice that we name the other template parameter something other than that of T, not T but TT. See, TT, right? So this is that there is why there has to be some consideration when you using your friend class or using friend functions. So this was about templates, but this was just a basic idea. You have to go into the detail, because if templates, though they solve our problem, but implementing them can create more troubles also. Thank you.